school, a group of students were performing experiment on biological specimen. The teacher showed them a jar with a pungent smelling liquid and told students to immerse the biological specimen that they are examining in the jar after the class is done, so that they can be preserved. One student asked the teacher, "What kind of liquid is this?" The teacher answered that it is formalin, which is a mixture of formaldehyde and water. The teacher also further discussed that formaldehyde is the first member of aldehyde family, which is also known as methanol, which contains carbonyl group and is a colorless and flammable gas that has a very pungent smell and is soluble in water. In this video, we will discuss other such properties of carbonyl group. Let's start with the physical properties. Except formaldehyde, which is a gas, all other aldehydes and ketones up to carbon 11 are liquid. Still, higher member are solids. The boiling point of aldehyde and ketones are lower than alcohol or acids of comparable molecular mass. The reason is that dipole-dipole interaction in aldehyde and ketones are not as strong as intermolecular hydrogen bonding in alcohol. The lower members of aldehyde and ketones, such as methanol, ethanol, and propanone, all are miscible with water in any proportion because they forms hydrogen bonding with water. However, the solubility of aldehydes and ketones decreases rapidly on increase in the length of alkyl chain. All aldehydes and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. The lower aldehydes have a very sharp pungent smell. As the size of molecule increases, the odor becomes less pungent and more fragrant. In fact, many natural occurring aldehydes and ketones are used in the blending of perfumes and flavoring agents. Now, let's discuss the chemical reaction shown by aldehyde and ketones. Since aldehyde and ketones both possess the carbonyl function group, they undergo similar chemical reactions. In carbonyl group, oxygen is more electronegative and thus the electron pairs are shifted towards oxygen. Due to this, the polarity develops. A highly characteristic reaction of carbonyl compound is the nucleophilic addition to carbonyl group. The reason for this type of reactions are the polar nature of carbonyl group. Due to this, carbon becomes electron deficient, which can be attacked by a nucleophile. Second is the ability of carbonyl oxygen to accommodate negative charge. Third is the coplanar arrangement of atoms or groups attached to the carbonyl carbon, which makes carbonyl carbon open to attack from the above as well as from the below. Let's discuss the mechanism of nucleophilic addition reaction. First, a nucleophile attacks the electrophilic carbon atom of the polar carbonyl group from a direction approximately perpendicular to the plane of sp2 hybridized orbitals of carbonyl carbon. The hybridization of carbon changes from sp2 to sp3 in this process, and a tetrahedral alkoxide intermediate is produced. These intermediates capture a proton from the reaction medium to give the electrically neutral product. The net result is the addition of nucleophile and proton across the carbon-oxygen double bond. In general, aldehyde is more reactive than ketones in nucleophilic addition reaction due to steric hindrance and electronic reasons. The alkyl group linked to carbonyl carbon pushes electron towards carbonyl carbon and thus decreases the magnitude of positive charge on it. It makes it less susceptible to nucleophilic attack. The presence of 2 alkyl group in ketone hinders the approach of nucleophile to the carbonyl carbon. In aldehydes, there is 1 alkyl group and thus the nucleophile attack in this case is relatively easy. Therefore, we can say that formaldehyde is more reactive than any other aldehyde. Let's now discuss some important examples of nucleophilic addition and nucleophilic addition elimination reaction. Let's start with the addition of hydrogen cyanide. Aldehyde and ketones react with hydrogen cyanide to yield cyanohydrins. This reaction occurs very slowly with pure HCN. Therefore, it is catalyzed by a base and the generated cyanide ion, being a stronger nucleophile, readily adds to carbonyl compound to yield corresponding cyanohydrin. When sodium hydrogen sulfite is added to aldehydes and ketones, it forms the crystalline addition products. The position of the equilibrium lies largely to the right-hand side for most aldehyde and to the left for most ketones due to steric reasons. Aldehydes and ketones are added to Grignard reagents, that is, alkyl or aryl magnesium halides, to form addition products which on acidic hydrolysis yield alcohols. Formaldehyde on treatment with Grignard reagent followed by acidic hydrolysis yield primary alcohol, whereas other aldehyde forms secondary alcohol, while ketones yield tertiary alcohol. Aldehyde also reacts with 1 equivalent of monohydric alcohol in presence of dry hydrogen chloride to yield alkoxy alcohol intermediate known as hemiacetal, which further reacts with 1 molecule of alcohol to give a gem dialkoxy compound known as acetal, as shown in this reaction. Whereas ketone do not react with monohydric alcohols but reacts with diols. For example, it reacts with ethylene glycol under similar conditions to form cyclic products known as ethynyl glycol ketyls. Dry hydrogen chloride protonates the oxygen of the carbonyl compounds and therefore increases the electrophilicity of the carbonyl carbon, facilitating the nucleophilic attack of ethylene glycol. Acetal and ketyls are hydrolyzed with aqueous mineral acid, yields corresponding alcohol and ketones respectively. Next, let's discuss the addition of ammonia and its derivatives to carbonyl compound. Nucleophiles such as ammonia and its derivatives add to carbonyl group of aldehydes and ketones. The reaction is reversible and catalyzed by acid. The equilibrium favors the product formation due to rapid dehydration of the intermediates to form the final product. We have discussed various properties of aldehydes and ketones. We also know that both aldehyde and ketones possess the carbonyl functional group. Now, can you differentiate between aldehyde and ketones on the basis of chemical test? Well, we will discuss this in the next video. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.